Hello, everyone. So we have another MathCon problem. So this was a 7 points value. So we are given x and y in between 1/5 and 15, and then p is equal to the sum of the 3 over x and 4 over y. And then we just like to find how many possible integer value for the p. So like it says integer for p, so it doesn't says anything about x and y. So meaning that x and y could be any real number. So let's try to like kind of find the boundaries first, because that's going to tell us what other words like available like values for p. So like if I want to like try to get the smallest value of the sum, like since we're going to divide 3 by a number, 4 by a number, if you want to get the sum to be smallest, then you want to choose x and y to be as large as possible. So the it says x and y could be less, like should be lesser than 15, but let's try to kind of find like the optimal value. Let's say if this was available for 15, so if I plug 15 for x, so you will get 3 over 15 and then 4 over 15, which we know for sure x and y are not equal, but let's go with these because we're going to say if this is going to give us anything on in terms of our boundaries. Like, so that will be like 7 over 15. So meaning that the p, which is this is our p, cannot be 7 over 15, but it has to be larger than this because I choose x and y as large as possible, which is like I choose 15, but none of these could be 15, so it could be really close to 15. Let's say like 14.9999, and then this, like I can say this is like 14.9999, and then this is 14.9998, and something like that. So which means even though we are not allowed to choose 15, but I can really kind of get close to that. So which is why I choose 15 for both, and that will give us this one. But this is not achievable because x and y is not 15, meaning that p has to be larger than this. Okay, so 7 over 15. So like you might be asking how can we like get something like this larger than this? This is like one approximately like 1/2. So which means p has to be larger than 1/2. So it could be like 2, 3, whatever, in terms of integer. And then if you are wondering, is it like really possible to choose like 1? Because this is 1/2, so it's possible to get 1. Like we can try that. Like it's not going to be challenging because if I choose, let's say 6 for this and then 8 for this is 1/2 and this is 1/2, and then x is 6 and then y is 8, so which satisfies the condition. So which means 1/2 plus 1/2 is 1, so p is actually achievable with 1. So, and then we can try another different values, but I don't really need to think about these because we know that there are infinitely many real values, so we can actually get any integer when I plug into these. So let's find the largest values achievable. If I want to get the largest p, I need x and y to be as small as possible, which is 1/5 in our case. I can try. So that will give us like 3 over 1/5, and then 4 over 1/5. So if I go with that, so this will be just 15. So, and then this will be 20, which is 35. But this is not achievable because I choose 1/5, which is not available. So it has to be lower than 35. So meaning that anything between like 1, 2, 3, all the way to the 34 is achievable, but nothing else. So we have 34 integer value of p. So I hope that was clear. I'll see you in the next video.